Scientific progress continued with the work of Galileo and Kepler and Newton. And what they did is they realized that the universe follows, the natural objects of the universe follow very, very simple natural laws. And this is something that they realized mathematically, and they have found a mathematical equation which describes all these heavenly motions. So again, we have a totally different picture of the universe. What hadn't changed, though, was the question about whether or not the universe was infinite in time, infinite in spatial extent. In the Newtonian conception of the universe, we had all these galaxies spread out in the universe, and basically things were static. Maybe galaxies were coalescing and planets were coalescing and things like that, but overall, the overall picture of the universe was an infinite, static, eternal universe. Everything had remained the same, roughly speaking. Because the space and the time was there. It was a given. There was space, there's time, that doesn't change. And in this space, over the period of time, was this distribution of galaxies. What was missing in the Newtonian picture of the universe was space and time. And that had to wait until Einstein came. Einstein was the first one to put the finishing link in this idea of the universe in terms of eternity and infinity. There's something scientifically, though, missing in that theory. What is that theory about? That theory is about the matter in a pre-existing universe. There's an infinite universe, eternal, and in it there is matter, and gravity kind of dictates how that matter will interact with each other. But what about the universe itself? What about that which all this matter is within? Without having a theory of that, you don't really have a theory of even the material universe. And that's where Einstein steps in. Modern science has extended that kind of investigation, and through Einstein's theory has come up with a way to understand some of the basic conundrums. Now, Einstein's theory, and I'm going to present some of that to you, came up with very, very beautiful, clever answers to both of those questions, something that philosophers had been grappling with for thousands of years. And what Einstein did is he came up with a theory not just of the content of the universe, but the space-time of the universe, the fabric, the universe itself, rather than just what the universe contains. Newton had come up with a theory based on gravity, which gave some kind of an account of how it could be that all the matter in the universe would agglomerate into clumps, and Laplace as well after that, so that you would have maybe the equivalent of what we would call today galactic formation, and then maybe some kind of cosmological view of the universe as a whole. But again, it really wasn't the universe, it was the contents of the universe. Einstein's theory addressed space-time, not just the content. And his equations related the content of space-time to space-time itself. That was something which then allowed science to grapple with the questions of space and of time. And basically, what turns out is that one can imagine, and this is something that you have to use an intuition that kind of develops with time, to understand how it could be, kind of like in a video game or any kind of screen where something goes off one edge and comes off the other edge. If you can imagine space having the property that it is warped, curved, whatever word you want to use, so that there's no actual ending. It's not like a screen which has a finite ending, and here's one end, and here's another end, and you go off here, you come here. But there is no end. But on the other hand, it is not infinite. It's warped in such a way that if you go and go in the same direction, you will eventually come back to where you started from without ever having passed some kind of wall or boundary. Now, it sounds impossible, but mathematically one can construct sets which have these properties, and it's all self-consistent, and it works. And therefore, there's absolutely no reason why it can't be that space, physical space, has the same properties. And Einstein's model proposed something like this, which then was a solution. Now, it doesn't mean that cosmologists today necessarily assume that the universe is finite, but this was a way in which science was able to come up with a solution, a resolution, of a conundrum that plagued humanity for thousands of years.